Math in 3 with Mrs. Z.
This video is about factoring with difference of perfect squares. This can only be done when you have two terms in the quadratic. So when we factor a quadratic, the first thing that we always check for is a GCF. Once we've determined if there is or is not a GCF, we then have to determine how many terms are in the quadratic. We're going to focus on if we have a binomial. A binomial is some quadratic that has two terms. So if our quadratic has two terms, the way in which we are going to factor it is called difference of perfect squares. With difference of perfect squares, we need to make sure we have subtraction, and we need to make sure that our first term and our second term are both perfect squares. So 9x squared is equal to 3x times 3x, and 7 times 7 gets me to 49. Since those are exactly the same, we have what's called difference of perfect squares. When we factor, the 9x squared came first in the binomial, so the 3x comes first in the parentheses. The 49 came second, it was the second term, so the 7s are second. We multiply to a negative 49, so our signs for 7 have to be a positive 7 and a negative 7. That's difference of perfect squares. Whenever I do difference of perfect squares, I always like to list out the perfect squares on my paper from 1 to 15. So 1 times 1, 2 times 2, all the way up to 15 times 15. This helps me be able to spot them a little bit easier. All right, so let's take a look at this example. We have 3a squared minus 3. The first thing in my flowchart to look at is a GCF. I notice that I have a GCF of 3 here, so I'm going to divide that GCF out, and that goes in front of my parentheses. 3 divided by 3 leaves me with 1. 1 times a squared is a squared. And then that 3 divided by 3 is 1, and we're just going to leave it as 1. So then I have a squared, and that's equal to a times a, and we also have 1, which is equal to 1 times 1. Since we also have subtraction, that means that we have difference of perfect squares. The GCF stays out front. I set up my parentheses. We have a and a. We have our 1 and our 1. Remember, we have to multiply to a negative 1, so 1 positive and 1 negative. And there is your final answer, where you have a GCF followed by difference of perfect squares. All right, second example, 16a squared minus 81. I'm going to check for a GCF. I do not have a GCF. I do see that both 16 and 81 are on my list, so I know that they're perfect squares. 16a squared is equal to 4a times 4a, and 81 is equal to 9 times 9. So I set up my parentheses. We have that 4a, and the 4a, it was the first term in this binomial, so it's the first term when I set up my parentheses. That 81 gave me the 9s, so I have 9 and 9. We multiplied to a negative 81, so I have opposite signs of plus and minus.
This was Math in 3 with Mrs. Z. Please like and subscribe below. Thanks.